Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# user group. A little bit about the group. We meet every fourth Thursday of the month. Meetings are free of charge and open to the public, and you can find meeting information on meetup.com, and the link will be posted in chat in just a little bit. A little bit about the group. We always like to keep the meetings casual and open to questions and comments, so feel free to jump in at any point in time. However, we want to give our speaker enough time to go through the slides and the demos. You'll be able to ask questions as we go, in addition to have a Q&A period at the end. I would like to give a big thank you to our sponsors, PostSharp and DevExpress, and as well as NIS Technologies and the .NET Foundation. Tonight's speaker is David Pine. David is a Microsoft developer relations expert at Microsoft. He focuses on .NET and Azure developer content. He is recognized as a Google developer expert in web technologies and is a Twilio champion. He's also an O'Reilly Media author on learning Blazor. He develops community engagements through speaking at user groups and conferences. And he's an advocate for open source and the .NET Foundation, which includes C#, TypeScript, SignalR, and a variety of other technologies. And if that's not enough, he's also the co-host on the .NET Live stream, and he's part of the .NET Live TV family for streaming shows. And with that, I will turn it over to David. David, thank you for joining us.
Awesome. Thank you so much for having me, Sam, and I'm excited to be here. So thank you so much for the warm welcome and introduction. So this talk is, we're going to be talking through Blazor Raiders, which is just a play on word. But we're looking at C# source generators specifically for Blazor. And the introduction that Sam was so gracious to provide covered most of the things already. But as he mentioned, I'm a host on .NET Live, which is a TV, not a TV series, but like a live TV on .NET show. And I work in developer relations at Microsoft. You can follow me at David Pine7 on Twitter, and I also own Blazor Bits, which is like helpful little tips for Blazor. All of the source code that you see during this presentation is available at iEvangelist on GitHub, and feel free to check out my website where I'm always blogging or sharing additional things besides blogging content. So, without further ado, I just want to jump right into the heart of the design goals for Blazor Raiders and really the meat of what it is. So from a high level, I wanted to create a source generator that would generate JavaScript interoperability bindings. So I knew that I wanted to rely on TypeScript declarations. If you're unfamiliar with TypeScript, TypeScript is a superset of JavaScript that allows you to basically have training wheels, and it gives you strong types, and it allows for statement completion and refactoring with confidence and things of that nature. I've been a long time advocate of TypeScript, but one thing that a lot of people are unfamiliar with is that there's this d.ts, and that's like the type definitions. Those type declarations provide you all of the API surface areas, the contracts for the return types, the contracts for the parameters, and all the typing structure is defined in those declarations. So my idea was to essentially read type definitions from TypeScript inside the context of a source generator, and then generate C# bindings to those different types. So the source generator has the followings. So there's going to be an interface, and it needs to be public partial, and the corresponding implementations for those interfaces would be internal sealed, such that we're not leaking our abstractions. I wanted to support generics through descriptors, and I'll get into that here in the demo. I wanted to support custom serialization, and I wanted to have like dependent types, because one of the things that you start getting into is when you look at various APIs from JavaScript and Blazor, there's callbacks and there's various parameters and the return types, and we have to figure out all those things. And then as an added, I wanted to make sure that we had dependency injection as a first-class citizen. So the design goals kind kind of laid out, with these things in mind, I set forth and started building this source generator kind of on steroids. And I wanted to make sure that we kept it simple. So it ended up growing, as all software development projects do, but I wanted to make it extensible as well. So there was some community members who caught wind of this effort, and they started, liking it. 7.1 million hearts. This is actually fake. I made that up, but I thought I'd put it there to make it look like it was really cooler than it is. But there are lots of people that were asking questions about it, and they thought the idea is great, and they have their own JavaScript libraries, and they wanted to start doing their own implementations. So rather than using TypeScript type declarations, maybe they could use other semantics. People love the project name, Blazorators, mount up, regulators, I guess, playing words there. Yeah, lots of people were super excited by it. So all of this is to just kind of build a case for source generators. If you've not really used C# source generators before, I'll be completely honest, they can be a pain in the butt. It's not easy. You have to explicitly target .NET Standard 2.0 for your source generator itself. And then there's some headaches when you start pulling things in, like dependencies and whatnot. But there's still a valid case for it in this scenario. If you've written any Blazor code whatsoever and you've had to rely on JavaScript, you had to do that through JavaScript interop. So rather than writing that type of code, that can be kind of mundane. So for me, this was a no-brainer to try to build something out that could automate that process when APIs were kind of concrete and weren't going to change. So the source generator from the top level, this is how just source generators work kind of in general. So you have your C# compiler here, as you may know. So then you have your source code that the compiler sees, and it's going to pick it up and do stuff with it. And there's n number of analyzers. Now, source generators are actually, they fall under the category of analyzers. You can use them to write diagnostics, but you can also then provide generated code, and that generated code becomes part of the compilation context of your own code. So it's like this little vicious circle, right? So it gets even more complicated when we start throwing in the idea that I had. And to be very clear, this idea, I had presented it to Microsoft internally, and we were filing for a patent. But the lawyers got far enough into it and said that it wasn't notable enough, or novel enough, so they abandoned it. But what was really the differentiator is it's building out dependency injection and implementations of services. So it's taking it a bit further than your typical things, and it's trying to be idiomatic to C# developers. So when you're compiling it, if there's a valid source generation target, we'll generate the interface, the other part of the partial. We'll then generate the corresponding implementation of that interface. We'll generate DI hooks, so extension methods on top of the iService collection. And then we'll generate any dependent types so that C# has a hold of those various types. And then that goes back into the standard compilation, right? And then that's your whole cycle for like the source generator at a high level. So let's take a look at like a canonical example. If you've used Blazor, or actually if you've used JavaScript whatsoever, if you've done any type of browser development or web app development, you're probably familiar with local storage. If you open up your browser right now and you hit F12, you go into the developer tools, inside the context of window, you can say window.local storage. And window.local storage has this interface. This interface actually comes from TypeScript, but the interface itself is still there, and it's implemented by window as local storage. So storage it has a length, it's got a void returning clear method, it has a get item that returns either a string or nullable. And then you can get, given the index, you can get the key, you can remove an item, and you can set an item. And at the point in time of writing this slide deck, this interface was defined in the libdom of TypeScript, which is the essentially the TypeScript's compiler's type definitions for all of the library DOM APIs that exist holistically for all browsers. So it was line 14,276. So, okay, that's interesting, right? So we have that interface and it exists and we know about it. So how are we going to ever consume it? Well, one thing we have to do is we have to take a step back and realize that Blazor has two primary modalities for how it's hosted. There's Blazor WebAssembly and there's Blazor Server. Those hosting models are only important really when you're doing JavaScript interop, because there's different implementations for each. There's different interfaces that exist. WebAssembly is nice because it gives you the IJS in-process runtime. So since you're actually executing on the client, you can do so synchronously as if you would be running JavaScript, kind of in JavaScript, right? So there's no, their boundaries are a lot less. Whereas on the server, you have to have the communication goes back and forth, and then the server has to say, okay, we're going to execute this JavaScript, go back out to the client, and then have the client run it, and then yield the response back to the server. And it becomes an asynchronous operation at that point in time. So those are key differentiators between the two different APIs to be aware of, especially when we're generating things. So we have a public partial interface. Now this is C#. The stuff we looked at before was a TypeScript type declaration. So you might imagine that that interface could be implemented in C# as this type of interface, public partial interface, iLocal storage service. We have our length, we have our clear, we have our get item, and notice that this is a generic type. We have our key, we have JSON serializer options. We then have a string returning key, the remove item, the set item. So this interface and its corresponding implementation can all be source generated. So we don't actually have to write that code. And that's the really cool part. So that was for the synchronous version. The asynchronous version looks like this, right? We have value task returning types. We have async suffix on our return methods and things like that to make it more idiomatic to what C# developers might expect. So let's get into a bit more of an elaborate example, right? Local storage is pretty straightforward, it's pretty hashed out, but geolocation. So there's a geolocation API that exists on all of our browsers as well. It differs in several ways. Now this is where we get into callbacks, but if we look at line 5,498 of the libdom declaration file in TypeScript, this interface looks like this. It's got a clear watch given the watch ID. It says get current position, but then we have postbacks or callbacks. So the success callback looks like this. There's a position callback. There's an optional, right, question mark here, optional callback for errors. And there's also position callback or position options. And then there's even a way to watch a position and get constant callbacks. So these callbacks and these different options here, those are non-primitive types. So when we're source generating this type of API, we actually have to go resolve those callbacks, those other types. So we have to then parse the libdom and then take those TypeScript definitions and then convert them over to C# for all of this. And they can go pretty deep. So when we first look at like the position callback itself, that looks like this. So line 17,957, the position callback is actually, it's essentially like a delegate at this point. It's saying it's a method that's void returning that expects the position, the geolocation position. Well, now we have to go look up geolocation position. And you kind of see where I'm going with this, right? So now we have to go find the interface for geolocation position. And this has two read-only things, the coordinates and a timestamp. The geolocation coordinates, this type has to be looked up as well because it's a full-on type. Also, when we look at the DOM timestamp, this is just essentially a number, or in TypeScript, it can be another variable as well, but essentially it's a number that represents milliseconds past Unix epoch. So let's look at the geolocation coordinates. You can see that there's some other read-only things. We can have accuracy, altitude, headings, latitude, longitude, and speed. So the interface might look similar to this. Public interface, I geolocation service, void returning, gets current position. But to be idiomatic to C# and Blazor developers, you would have to typically pass in a reference to yourself. So the T component that's asking for these things. And the reason is you're expecting these callbacks to be essentially JS invocable attributed methods that then can have JavaScript get a reference to the component that then call back into it later on. So let's show you what that looks like. But to be more idiomatic with C#, callbacks and strings and then passing in a reference, that gets mucky very quickly. So instead, it's very common to pass in delegates like this, like an action that takes a geolocation position, or an optional action that takes in a geolocation position error, or an optional position options, right? So this becomes a lot more idiomatic for C# developers. And that's kind of what we're looking for. That's, again, talking about the high level goal and building the source generator. So this is a screenshot of not only the source generated stuff in action, but so we've got protected, override, void, uninitialized. This is the uninitialized of the component. We've got a geolocation reference, and then we say get current position given the component, which is this, and the name of the callback that we're going to use. So this is JS invocable. So we get the geolocation position, and then we're even source generating the / comments. So the source generator is providing lots of additional context. So it's saying the onSuccess callback method name expects a name of a JS invocable attribute C# method with the following signature, a system.action of geolocation position. So this is immensely powerful for consumers of these outputs. So let's get into a demo. I'm going to stop sharing that screen and I'm going to share a different screen. Before I jump over to the demo though, are there any questions about this? I mean, this is all for you, and we've got a smaller group tonight. I'm happy to double click into something and go into more detail, but let me know if there's any questions.
I don't see any questions in chat, but I will definitely keep an eye on it.
Okay, perfect. Okay. So, Blazorators, I have the solution open here. Let me zoom in a little bit more. Go to 150. Does that look good for everyone? I hope so. All right. So the project itself it's a source generator, but there's also a few other moving parts. So the output of the project was initially to just be a source generator. But I have some samples, I have some unit tests, the core source generator itself. And the source generator is kind of the heart of all of it. It does all the heavy lifting. But as kind of a peripheral out of this, I started source generating deliverable packages beyond the source generator. So we've got geolocation and then geolocation WebAssembly, local storage WebAssembly, session storage, speech recognition, and speech synthesis. And these are entirely source generated. So I'll take you through a little tour briefly of the source generator itself. So when you're writing a source generator, you have to attribute your generator with generator, and this comes from the official Roslyn APIs. And then you have to extend iSource generator. And when you do so, there's an initialize method that it's expecting, and this is going to give you some context. Now, the really cool thing about this is you can actually set breakpoints. So if I'm compiling one of my deliverable NuGet packages, I can uncomment this line here, and it will break so that I can actually step debug my source generator, which is super cool as part of my compilation. So that's something that's fun. So with this context, we can register for syntax notifications, and then we've got our JavaScript interop syntax context receiver. It's a mouthful, but it's just looking for how it gets to be notified when the developer is doing things. But I'll get into that in just a second. The next really cool thing is you can add source code to the compilation in the form of text. So in addition to generating your stuff, you can then generate other things beforehand from just raw text. So we've got source code to add. So what I've done was we've got record compatibility. We've got the Blazor hosting model. So I'm going to go to these. So these are just string literals that are different things that are part of the compilation context. And this you may recognize as C# code. So we've got a Blazor hosting model enum that says we've got WebAssembly and we've got server. And then we've got, here's the record compatibility stuff. So since we want to use record types, when you're targeting 2.0, .NET Standard 2.0, you may run into this. So you have to just kind of have these placeholders for like using system component model, and then a namespace, which is system.runtime compiler services, and is external init. Yep. So once you have those things in place, you can use record types. But then here's what I wanted to do. So we start off with two different attributes. The first attribute is the JS auto interop attribute. So what I want to do is I want to be able to take this attribute and apply it to one of the interfaces that will then be source generated into a full-on service. So the / comments kind of talk about how it would be used, but then it's just C# code in the form of a string at this point. So it's got a type name, an implementation, and some other various options, and that's all well and good. And then we've got a generic version as well, because we've got different ways of describing things. But then we have all sorts of things that rely on doing an HTTP request to go pull down the TypeScript definitions and then parsing those and then using those to output things if they have this attribute. So I'm going to step over now into an example project. So when we look at this project, the Blazor local storage WebAssembly, the project itself has this many lines of code, 17 lines of code. I mean, there's white space in here and new lines and stuff like that. But it's a public partial interface local storage service, right? Now, when I'm hovering over this, you may or may not notice it says source generated interface definition of storage type. Well, I don't have any / comments on this interface definition right here. So where's that coming from? It's a partial, and partials are used very, very liberally for source generators. So this is the JS auto generic interop. So this attribute that you're seeing is source generated. It's from that raw text file. It's now part of the compilation. Since this project is referring to the source generator, it has access to this type, right? So the / says, you use this attribute on a public static partial. It's like based on it was originally based on extension methods. I should update that, but it kind of gives an example of how you might use it. So we have our type name, right? So the type name is storage. Now, if you recall looking back at our slides, when I showed you that interface from the TypeScript type declarations, there was an actual interface called storage, because there's two different implementations in the web. There's session storage and there's local storage, and in the future there may be others. The implementation, this is how we navigate to that type from JavaScript interop. We want to say it's on the Windows scope, and you say window.local storage. So if you were to open up a browser and you were to go, F12 and go into your console and type window.local storage, you will see this implementation in your browser. We have a URL. This points to the Mozilla window local storage so that we can actually generate meaningful triple/ comments for these APIs. Now, generic method descriptors, this allows us to do a few things a bit differently. So what this allows us to do is specify a bit of contextual additions to the way that we're source generating. So rather than being like our get item, we know that there's a get item on this interface. We're saying we want get item to return a generic type. And we're saying that we want set item to allow its value parameter to be a generic type. So given these little string array descriptors from our attribute definition here, we can actually define that behavior. So when I compile this 17 lines of code, and again, that's all there is 17 lines, you will get a fully functioning DI ready functioning service that is going to resolve this to an implementation that is powered by Blazor JavaScript interop. And I will show you what I mean by that. So as you can see here in this project, this is the only code I have. So if we go to dependencies, and remember I said source generators live under analyzers. We look at analyzers, we can see, there's many Microsoft things here. There's different, system text, regular expressions, and system text JSON, and other source generated stuff, which is great. And then here's mine, Blazor.source generators. So if you expand this, you can just continue to open up and see what else is in here. So let's go to one level down. Now remember I said it creates and you can see here, this file is auto-generated by the generator blah and cannot be edited. So this is read-only mode. So this is the public enum, the Blazor hosting model, WebAssembly server, right? So that's source generated as part of the context. We also have the attribute. This is the attribute that we created. So we say nullable to enter the nullable context. And this looks like regular C# code at this point, right? Pretty neat, pretty powerful. We've got the generic version here that talks about how to do generics and type descriptors, and it's essentially a subclass of the auto. So we have inheritance even going on here with our attributes that are generated. So here's the fun part. So this is the corresponding partial. So we have public partial interface I local storage service. So this from our original, let's go back over here real quick. From our original, where is it? Right here. From this little bit right here, this is the code I wrote. And since it's a partial, the source generator generated the corresponding other partial that defines the interface. So as you remember, clear has it corresponds to the web API storage implementation of clear, and get item is get item, but it has generics and it has nullable and it has overloads for serialization. And we've got the key and we've got the remove item and we've got set item and we have read-only properties and things of that nature. So all of this is source generated. So that's the interface, which is great. Let me show you the corresponding implementation. So this is the implementation. So the implementation is an internal sealed class. So this implementation is never leaked to the consumer. They can only use the I local storage service from dependency injection, and we'll show those hooks in a second. But what we say, since we're doing WebAssembly, we want the IJS in process runtime, and we get that through dependency injection here. And then we have our corresponding inherent docs for triple slash. We explicitly implement the interfaces, and we just walk up to our JavaScript instance and we say invoke window.localstorage.clear or local storage get item, where t value is a generic given the string, with the overloads for the serialization, where T is constrained to default, and we have serialization overloads, and it gets pretty compelling. So let's see. So that we automatically generate these extension methods too. So the extension method here is add local storage services. So this method could be called when you're registering your Blazor app, whether or not it's server or client, server or WebAssembly. You'd have to choose which package appropriately, but then you would just walk up to it much the same way you would any other, open source project, and you'd say add whatever type of services it is, and it registers it as a singleton. So it gets the IJS in-process runtime, and it maps the iLocal storage to the local storage implementation. And what's really cool is I have some samples here as well. So it's an example consumer of it. So this is a Blazor WebAssembly app, and we look at the program CS. This is a C# top-level program. This, if you've done Blazor development, this will look very familiar. Now, here's the cool stuff. These right here are all source-generated extension methods. So the add local storage services. So that's pretty neat. So once we've added that, inside the app, wherever we're doing things, we can, let's see here, so we can ask for dependency injection to inject our implementation. So we can say local storage service, that's coming from the source generated stuff. And once we have it, we can interact with local storage. So we can get items of full-on record types or whatever it is. We can provide contextual bits of information for how we want those things to be exposed. And it's really, really cool. Let's see, what else? Let me go to geolocation. So let's jump back over into geolocation. So geolocation was the other example that I had shown. This is only 12 lines of code, right? So we have our namespace, our copyright, the JS auto interop. We've got our type name. So this, as you might imagine, there's a geolocation interface that exists. And if you're to open up your browser window, you can say window.navigator.geolocation. That's where it's coming from. And the geolocation APIs are under this URL. And again, it's a partial. And what did Blazorators do for this? So it actually generated a whole lot more. And the reason is because the generator had to resolve all the different dependent types for the APIs that existed. So let's go into the local storage partial. The geolocation service partial implementation that was generated. So we've got a clear watch, which is void returning given a double watch ID parameter. So it's pretty straightforward. But this is where things get really fun. So we've got a void returning get current position, and then I provided an overload for the idiomatic parts that we wanted C# to be, kind of showcasing. So you can do it the old-fashioned way, where you say, here's a reference to the component, and here's a string that will map to the method name, and that method name will be JS invocable, and with this reference of it, JavaScript will actually call back onto it and invoke that. But we also generate this overload, which is the action delegate-based one, which is more preferable and more idiomatic. So that's all well and good, but so let's look at some of these other types here. So you might notice like geolocation position. So that's also generated. And we have the JSON property names for it, because these things have to be serialized for interop to work correctly. And you may have noticed like we have a DOM timestamp. So whenever the source generator recognizes that there's a DOM timestamp, it knows that it's just a long, and that the long is milliseconds since Unix epoch. And with that, we have another extension method for convenience that will take it and convert it to UTC. So given this timestamp, we've got a to date time from Unix. That is, this extension method is kind of encapsulated away and hidden inside there. But you have a read-only date time that takes the timestamp and says timestamp as UTC date time, because that's probably how you would want to consume it in the context of C# and .NET. So then we've got the position coordinates. We generate the position error in the event of something like permission being denied. That's where things get really cool, is because even though this is source generating all of these various implementations and types for you, it's generating a NuGet package that can be consumed by anyone around the world, and it just works. So it's let's see what else here. Let me go. Well, actually, let me do this. Is there any other code that you guys want to look at within this app? Otherwise, I can show you the app running. My sample app is it's a WebAssembly Blazor app, but in my Blazorators repository, whenever I publish NuGet packages, I also push out the sample as a GitHub pages. So I have that too. So I'll stop sharing real quick and we'll go look at that because that's fun. Share. Okay, this one. Okay. So under iEvangelist, Blazorators, which is a terrible name, that's where the project lives right now. I humbly appreciate stars. So if you find this interesting, please give me a star. It's been a lot of work. I've just been doing it all in my free time, and but there's, as I mentioned, there's several different kind of aspects to it. The two primary things are the source generator and the serialization library. They kind of go hand in hand. But then there's the deliverables, like the things that are like outputs of this effort. So there's blazor.localstorage.webassembly, blazor.sessionstorage.webassembly, blazor.geolocation.webassembly, speech synthesis, and then there's the server-side bits for them, and the README kind of goes through all that. But over here on the About, there's a link that takes you to Blazorators, which is the web page to test out all the different things. So to showcase local storage, we can say, here is a to-do. We'll add that, and we can say this is another, how about this? Impress the people I'm showing this to, hopefully. And then we can set the different state. Now, here's what's cool. Since this is local storage, if I was to navigate away and come back, this would be an empty list again. So let's go back and come here, and you can see this is the raw local storage. I'm showing all of the various local storage items here, just for like readability, just so you can see what's going on. Yeah, so it's all just in the browser using local storage, but it's all source generated. So all of the APIs are from C#, and the JavaScript interop kind of just melts away. You don't ever have to think about that because it's source generated. So the other cool thing is geolocation. So this page starts off by saying, and this is where I live right here, it's my house. Got different road views. Let's go aerial. So if I was to say permissions, location, and say ask, and close this out. Now it's going to want me to refresh the page, of course. So I'm going to refresh the page. Now, if I say block, we're going to get one of those errors back. So that's the geolocation position error object that I'm showing here instead. So it says user denied geolocation, which is kind of neat. So I can go in here and let's just say that we'll say ask again, and then it'll ask us to reload. And if I allow it, that's when it actually works. Then what's happening is the JavaScript, the C# code is saying I have this get current position API, and it's going to go resolve the JavaScript interop service, and it's going to go invoke the corresponding JavaScript on, here in the context of the client, and it's going to say, hey, this requires special permission. So it's going to prompt your browser, and based on your actions, the C# stuff just follows the suit of all the stuff underneath it. So it's pretty neat. In addition to that, we've got speech synthesis and speech recognition. Now, admittedly, some of these required a little bit of hand-holding. Like I had to write a few bits of JavaScript that would sit on top of it that would then also be considered potential candidates for generating later on. But I'm gonna ask you guys real quick, I'm gonna play some audio. I wanna know if it comes through on our meeting here.
Blazorators is an open source project that strives to simplify JavaScript interop in Blazor. JavaScript interoperability is possible by parsing TypeScript type declarations and using this metadata to output corresponding C# types.
And Sam, did that come through?
Yeah, loud and clear, but it sounds like she's a little over caffeinated.
Yeah, we can adjust the speed. We can pick any number of voices here. Let's pick Anna at a speed of 1, and let's say, thank you all for this opportunity.
Thank you all for this opportunity.
That's Anna. Okay, so then we can do speech to text. So that's text to speech. I can say whatever I want, and it's going to pick it up. And this is again using JavaScript interoperability. And whenever I pause, it will automatically kind of pump that through the system. But this is again using the client native browser stuff, but it's all, you know, source generated C# that sits on top of it. It's pretty close, right? So the other thing is there's a track API that exists. So you can watch a position. And I put the timestamp up here because, you know, it's 51 right now. So how does the callbacks work in the context of Blazor and JavaScript? And so it actually has to have a reference. So it's got that request or that action delegate, and it's firing off every so often, keeping track of your stuff. And yeah, so that is Blazorators, and I'm hoping to add a lot more. Let's do this real quick. I'm going to jump over here, stop sharing. Let's go back to the slides. Share slides. Perfect. All right. So that was the demo. So the future work is actually I have a branch for it right now, and I've been working on it for months, and I'll admit that openly. But I'm re-implementing the TypeScript abstract tree syntax parser, so AST parser. I'm re-implementing that from TypeScript because it's used for its compiler in C#. And the reason I'm doing that is I'll be able to read any arbitrary TypeScript file, and rather than brute force, you know, reading and using regexes and stuff like that to kind of find in different things, and I'll be able to actually have like an AST that represents the various things from TypeScript, and it will be a much easier effort to expand this tool to you know, adapt other libraries and other things like that. So that's what I'm working on. So I'm busy, and it's awesome, and I hope you guys enjoyed it. I hope you learned something from this. I just hope that you enjoyed it. So there's all sorts of resources here. So you can go to aka.ms/Blazor/source-generators. That will give you the resources for this. Additionally, there's a bunch of other resources here for the NuGet packages. This is just all of the NuGet packages. All of these NuGet packages, I just checked. I just recently got up to 115,000 downloads, which isn't a huge number, but for something I just started doing kind of on the side for fun, I'm, you know, proud of that. And as Sam graciously shared before, I'm the author of Learning Blazor, Build Single-Page Apps with WebAssembly and C#. So Blazorators was actually born out of me writing the application to serve as the basis for this book. So I have, I don't know how we didn't really figure out any logistics here, Sam, but I have a hard copy of the book here, and I will happily sign and ship this to one of our lucky attendees today that are watching. I'll let you figure out the logistics of who that lucky person is. I don't know if we have a randomizer or something like that. But yeah, yeah, like I said, I'll sign it and I'll send it over, mail it to you. You just have to agree to give me your address so I can ship it there. But with that, thank you all so very much. This was a lot of fun. I really enjoyed it. I hope you got a lot out of the presentation. And I'm here to answer questions. So feel free to come off mute, share your beautiful faces, and interact. Happy to stick around.
First of all, great presentation.
Thank you.
But second of all, I got a question for you regarding the text-to-speech. So am I right in saying that you were using a JavaScript, or you were going through Blazor, and then you were making a JavaScript interop call to make the call to the Azure text-to-speech service? Is that right?
It's a very good question. No. Let me actually share real quick this. So everything that comes from the libdom is, I'll open up, let me put this in here. Give me 1 second to adjust a few things. Put it over here, don't dock, put it in the bottom. All right, so now you can see my big obnoxious console window, right?
Mm-hmm.
Okay, so inside the console, I'm gonna actually cheat real quick because I wanna look at to see where this API lives. Typing, speech. So there's a speech synthesis that exists native to the browser and speech recognition that exists native to the browser. So I'm not using any third-party JavaScript package, and I'm not using any Azure functionality. That is all native to your client browser. There's official APIs that exist. So speech synthesis dot, let's see here. Let me see. So that actually, I think it's a like const utterance equals new speech utterance. Yep. This is so cool. And then I have that utterance, and I'm going to go speech synthesis. Yep. Dot speak that utterance.
This is so cool.
Yeah, you heard that?
Yep.
So that's all native to your browser. You can do that right now. You can open up your browser, hit F12, and those APIs exist. And that's the only thing that I'm source generating from. That's why it's a bit restricted right now, is I'm only using the stuff that's native to your browser. So the idea is to expand it further and use other potential libraries as candidates, but right now it's limited to just that.
So this is standard in Chrome and Edge?
Chrome, Edge, God, I think it's all over. So let me pull up. Can I use real quick? Can I use? Are you guys familiar with Can I use?
I am.
Speech. I'm not sharing. Speech synthesis API. I'll share my screen again, real quick. Here we go. So I just did speech synthesis. And then almost 96% of all browsers around the world support this natively.
So for those that are not familiar with Can I Use, can you give us just a brief explanation of what that site is all about?
Yeah, so caniuse.com is a great way to kind of recognize various APIs that are standardized. So the ECMAScript committee gets together and they standardize all these APIs, but it's actually the browser vendors that are responsible for implementing those APIs. And there's no guarantees that that happens. Can I Use kind of fills that gap in helping us realize what APIs have been satisfied per the spec on each of the various browsers. So it shows like Chrome, Edge, Safari, Firefox, Opera, IE, Chrome for Android, Safari on iOS, Samsung Internet. It's got all of this stuff here. Every major browser is going to have this information in here, and it lets you know if these APIs are available. And this is like a holistic, like global percentage of kind of market share of the vendors that provide these implementations for these various APIs that are standardized from the specs, and it lets you kind of type things in. So like you might ask yourself, well, is WebAssembly something that's standardized, or is that everywhere? That's 96% globally. So yep, you can use this for looking up anything. We can do like local storage. Does that exist? That's 97% almost, right?
Yep.
Cool.
It's a very useful site, especially when you're dealing with public internet sites, because you have
Absolutely.
no idea who's using what version of what browser.
Right.
So it's a great way to identify why something isn't working.
Absolutely.
Yeah. Does anyone else have any questions for David? Feel free to come off of mute or enter it into chat, whichever is easier. And while we're waiting for questions, as far as the book, what we're going to be doing is using the meeting eval forms that are already posted into chat. Folks can fill those out, and then I will randomly choose from them, and one of them will be the lucky winner. And then
Awesome.
I'll communicate with you as far as address and shipping and all that.
Cool. Yeah, it was a labor of love. I spent a lot of my life writing this book.
That's what every author says. Yeah, it's definitely a good portion of your life. That's for sure.
I will never do it again. No. Awesome. Well, thank you all so much. And yeah, if you have questions, don't be shy. This is for you. I'm happy to help out. I love helping people. I thrive on that. So I know you guys are from Cleveland. I'm from Wisconsin. So Midwestern here. Let's talk. Any questions?
Appreciate it once again. Before folks sign off for the night, I just have a couple wrap-up announcements to go through. So first of all, there are links that are posted in chat regarding where the presentation will be posted. It's going to take a couple days to edit it and upload it to YouTube. The link to the YouTube channel is there. If you would please subscribe, and you'll get notifications when there's new content posted. Tech events are posted on my blog, samnasser.blogspot.com. And if I may, let me go ahead and share my screen. So as mentioned, we have the resources for the YouTube link, as well as tech events that are going to be already posted on my blog. And those are on May 2nd, there is the Ohio North database training, which is a SQL Server user group. Obviously, if you're working in .NET, chances are you're working with a database. And so this is a good group to network with. On May 10th, which is the second Wednesday of the month, is the Azure Cleveland user group. Currently, we do not have a speaker lined up yet, but we certainly will just in time for that. And then on May 18th is the Great Lakes user group for .NET that they are virtual from Okemos, Michigan, and their meeting also starts at 6 p.m. online. And then on May 25th is the May meeting of this Cleveland C# user group. With regards to conferences, on May 5th is Stir Trek. That is an event that's happening in Columbus. Tickets are $170 for that, and it's an all-day event. And then in the end, you have the private screening of a movie, and the information can be found at stirtrek.com. Stirtrek.com. May 11th through the 13th is the Global Azure 2023 event, and that is a 4-day event of almost 24-hour content that runs nonstop throughout those 4 days. Speakers from all over the world regarding various topics in Azure. So it's definitely a great event to check out. And then on May 20th in Akron, Ohio, is going to be the Ohio North SQL Saturday user group. It's a conference rather. And as the name suggests, it's held on a Saturday, and it covers a variety of topics related to SQL Server. So I will be there, and I'll be speaking on using artificial intelligence programming in T-SQL using Python. There's also going to be a variety of other tracks and speakers that will cover various aspects of Azure, SQL Server, and of course how to integrate with those in .NET. In addition, some other things I always like to cover, job openings. You can always check out job openings at techsystems.com/IT-jobs. In addition, if you have a job that you're looking for, if you have an opening at your place of employment, please feel free to make it known either in chat or verbally. And Last but not least, my contact information, my email if needed, snasser@nistechnologies.com. My Twitter is @SamNasser. The blog where I post tech events as well as various articles, samnasser.blogspot.com. And lastly, if we're not connected on LinkedIn, I invite you to do so. And so with that, thanks again to David, and thanks to all who attended, and look forward to seeing you all next month. Good night, everyone.